Okay, so okay. All right, so we are recording, so everything from here, and I'll put it up on online help sessions, and it'll be by date. Okay, so you'll know. I got some people in chat. Having trouble number 19 and 1.4. Okay, I'll get that here in a second. All right, so on this one, let's look at it. All right, so first things first. So you first got to analyze the table and change in X and change in Y. So you basically are looking to see how is my X values changing. Now, if they're increasing, that's positive. If they're decreasing, then that's a negative change, okay? So from -4 to -2, that's an increase of +2. And from -2 to +2 would be an increase of 4, right? And then from 2 to 3 would be an increase of 1. All right. So that takes care of my change in X. Now let's look at my change in Y. From -16 to -11, that's a change up the number line of 5 spaces, right? -11 to -1 is a change of 10. All right. Now, I've got the rest of these are blank. I got a question mark there and a question mark what that one is. So we've got two things that we're looking at. Finding a missing change in X and then finding a missing change in Y. So the first thing that I would do is this 5 slope is change in Y over change in X, right? So that's 5 over 2, and then I have 10 over 4. And if you look at those, they, let me do this. When you simplify them, they all simplify down to the same unit rate. And what I mean by unit rate, that means when the denominator is a 1, that's a unit rate. So it's really changing 2.5 in the Y value when it's changing 1 in the X, right? So that helps us to get the first one, right? Because yeah, this is changing by 1, so this has to change by 2.5, right? So -1 plus 2.5 should be 1.5, right? Mm-hmm. So now if I look, so that's how I got the first one. Do you see what I'm talking about? So my change in X was 1. My change in Y has to be 2.5 for that combo. If my change in X was 2, then I'd have to change 5 in the Y. If it changed by 4, then I'd have to change by 10 in the Y, right? So that's how I got that. Now let's look at from 1.5 to 9 is actually 7.5, right? Mm-hmm. So what I do is what I think is easier. And in the first couple of problems in this particular section, we looked at giving you a slope and then giving you a change in X and asking what the new change in Y would be. And then we also done the inverse of that, saying, okay, here's a change in Y, give me the change in X based off of some more slope and equivalent slope. But I tend to do this. I just change in Y over change in X equals change in y over change in x. I set up a nice little proportion, okay? So this one is going to be my old one. So it could be this one, that one, or that one. Doesn't really matter, okay? Whichever ratio that I have right there of the slopes, I can put in for the old. I'm going to use 5 and 2. I could have used 10 and 4. It would still been the same thing, okay? Now I'm looking at my new, right, which would be these points. This change and then this change. Well, I need to find out what that change is, right? So my change in y is 7.5, but I've got not a change. Okay. All right, so all I did was just set up a nice little proportion, right? Two ratios set equal to one another, okay? So from here, you just cross multiply, right? So that's 5 delta x equals, what is that, 15? Right?
I see.
And then divide by 5. So my change in x actually is 3. So this question mark is really, guess what? 3. So 3 plus 3 is 6.
Okay.
Okay. All right. What was the other one? Because I know I got to go to, I think, 19. I think somebody said 19. Yeah. So what was the other one that you needed?
I think it's just that one.
Okay. So we'll go 19 real quick and look at this one. The graph shows the temperature function of graph. Okay. What is the difference in temperature between the surface of the ocean and the deepest level shown? What is the difference in temperature between the surface of the ocean? Let's go back up. Okay. Okay. I'm not sure. We should be able to just pull, okay, over what depth does temperature change more rapidly? Yeah, I'm not sure about that first one. I have to look at that. They're saying 18. The heck are they getting 18? Yeah, I'm not sure how they're getting 18 on that. The temperature at the surface is approximately 20 degrees C. Okay, surface, and then, oh, duh. But I don't see how they got 2 from right there. It's 20. And then there's 2. Okay. So here, let me show you what they're looking at now that I've figured out what the heck the question is really wanting to do. You take this over. All right, so the first one says, what's the difference between the temperature? So what they're saying is from here. So I've got 20 minus, and if you look right here, this is 5, and that's 15. So I would say about 2.5, right? I mean, it looks to be about in the middle, correct? Which would be 17.5. They're wanting 18 on that. Let me erase that and do that again, write that. Okay, so all they're doing is what is the span on the x-axis, basically? From where to where is my temperature fluctuating on the depth? So 20 to 2.5, which is, I'm saying a span of 17.5, and the answer that they've got is 18, so they're calling it 2. All right, does that make sense? Who had that? Let's see who asked that question. Mitzi. Yeah. All right. Yeah. If I wouldn't have looked at the answer, there's no way I'd have got that, because the question itself is just, it's too much ambiguity in it. So, yeah, that's probably the last time you'll see this problem. Okay. So let's see, what's the other questions that they ask on here? Over what depths does the temperature change most rapidly? Okay. So let's look. I'm saying, well, you're looking at, if we look at rates of change, like this would be one section. This would be another section. And then this would be the last little difference section. Okay, does that make sense? How you're looking at how is it changing? So let me go back and, is it from 0 to 2? Is it from 0.5 to 2? Is it changing most rapidly? Yeah, they're saying most, so it would actually be C on that, which would be, here you go, the blue part, right? This one, if you look at, if we rate them, if we rate these, this would be the third fastest, this would be the second fastest, and this would be the first, right? As far as how the depth is changing per the temp. So, yeah, so that would be C on that. And then what is the average rate of change with respect to depth in the region called the thermocline? Okay, so I guess we're going to straight line this. All right. So it'd be from here to there. So we'd want that point as well as that point, right? And when we're looking at 2 points, even though the graph is kind of doing its own thing, when we look at it from a linear standpoint, we're looking at it like a straight line. Okay, rate of change. So let's see, that's 0.1, 0.2, 0.3, 0.4. Okay, so 0.2 comma 20, and then that would be, man, I'd have to say that's probably 3 or 3.5 on the X. Oh, I just wrote that backwards on that other one, didn't I? Dadgummit. There. And then, comma, that would be 0.6, 0.7, 0.8. Okay. .2, 3, 0.8. The heck you getting? All right, well, we'll look at it. 3.8, 20.2. Okay. Yeah, that's okay. So change in X, change in Y. Oh, the negative 17. Sorry, I was looking at it. I was not seeing the negative 17. 20 down to 3 would be negative. 2.2 to 0.8 would be a change of 0.6. But it would be a negative change. Do y'all see why it would be a negative change? Because this is really negative 0.2, and that would be a negative 0.8. Do y'all see that? Which would leave me 0. Over that, and I don't have a calculator. Yeah, I do. Look at my bag real quick. All right. So 6, 17, boom, boom. 0.35, right? That's what I got. So let's go see what they got. The heck they doing that? I ain't get negative 28. We got the same numbers. They're wrong on this. That's the x-axis. Here's the y. Yeah, they've got problems on this one. So I'm going to scratch 19 because look right here, guys. X-axis, y-axis. Okay? It's change in y over change in x. And if you do the inverse, let me do the inverse of that. If you do the inverse of it, you get 28. That's wrong. Okay? So they've got it flipped around backwards on that. So that should have been 0.35. It should be the change in y over change in x. Okay? So I'm going to scratch that. So that one is going to go away. I'm actually going to report it, but I'll also take it off. Okay, so 19. Let me go back. Want to do this? Yeah. Let's go down to 19. 2057. Okay. Delete, remove, and then I'll publish that. Boom. And then we're going to go back over here and kill it off the other one so that people in the other class will have it as well. All right, so while I'm doing that, anybody got anything else on 1.4? Anything at all? There's a good bit of y'all on here, so.
On problem number 18 on part B, how does it want us to put our answer in?
Let's see. I've done an edit on the video and put it back up. You have to take that answer and divide it by 2. So let's see, that would actually be this one, right? This one, correct? This
Yes.
is, okay, so on, all right, so it's 1,500 meters per second, right? That's your slope, correct? So slope is 1,500 meters per second. And they're saying if the echo returns in 3.5 seconds, what is the depth, right? So if we look at that, that's really what these cancel. That would be 1,500 times 3.5, right? Which would be 5,250. And on my video, I put a little call out thing that said divide by 2, right? And the reason why you got to divide by 2 is the echo is hitting the ocean floor and then coming back up to the machine, right? So that time is accounting for the signal going down to the ocean floor and back up. So that would be a total distance of down there and back. So you would take 25 or 5,250 divided by 2, which would be 2625, and that's what would go in there. Because if you don't divide it by 2, then you've got an overall distance of going from the ocean, the top of the on the waves, down to the floor, and then back up. That's what the 5,250 is representing, and that's what I missed on when I was working it through on the original video. That's why I had to go back and do a call out and say, hey, divide by 2. So did y'all see that call out? Anybody watch that one?
No, I didn't see it.
I re-uploaded it. I fixed it.
I saw it.
Okay. Yeah. So it's there, but you've got to take that answer and divide it by 2. Okay. All
Okay,
right.
thank you.
All right. Okay. Anybody else got anything else on 1.4? All right. Okay. What other sections within chapter 2 do you want to look at? What problems in the other sections do you have questions on, or is that just the main ones that y'all have? Y'all got any more questions? Let me check, see how many people's on here. Ooh, we got 8. All right. Now y'all being quiet. Y'all just listening. That's all y'all doing, right? Kennedy, talk to me. What you got?
We have a question about number 11 on 1.5.
Yeah, sure. Let me get to there. Guys, don't be shy. Are y'all seeing the dates while I'm sitting here doing this? Are y'all seeing the dates on y'all's assignments? Like that 6-7 right there?
Yes.
Yes.
Okay. So you should all see that in chapter 2, the dates got adjusted to 6-7. So test opened up on 6-5. So you got 2 days to do that. I made the test invisible until the 5th because, guys, when y'all click on it, you have started your timer. So we had a lot of people click on the test, and they didn't take it. They didn't look at it. I mean, they were like 2 seconds. And then it was just dead time. So don't click on it until you're ready to take it, because when you click on it, it's on like Donkey Kong, okay? So, all right, Kennedy, which one on this one now? What you got, Kennedy?
Sorry, number 11.
Number 11?
Yes, sir.
Okay. All right. I'm getting a little bit of echo. Oh. All right. Now, I did this one on the video. What got you?
Hold on, let me go back to mine.
And why you're doing
What is the Celsius temperature when it's 8 degrees Fahrenheit?
Okay. So let me go back to there. What is I don't see that. What is the Fahrenheit when it's 10 degrees Celsius? Oh, so they're giving you input and output right here. Okay. So is that what's getting you? How to solve for those?
Yes, sir.
Okay. Guys, I want to tell you, if you got an 83 or 84, TI 83, 84, which is what you need for this class, then you're going to be good. But if you don't have it, guys, you're not going to do well. You're not going to be successful because you're going to have to do this by hand, and I'm just not teaching all the algebraic theory needed for this. I'm showing you how to solve it efficiently on the calculator. So, all right. So what we're going to do, first thing we're going to do is we're going to type this equation right here, this part, right, into y1. Okay. So I'm going to my calculator. So let me get out of this. Click. I'm going to go y equals. I'm going to kill that. Right, so I'm going to go parentheses 9 divided by 5, close parentheses, hit x plus 32, right? That should be, yeah. Okay, so that's Celsius, that's input, and that's, okay. So I've got my equation in y1. Any questions about how to do that? Here's the key press history, and every button I press turns red on my calculator, okay, so you can see that. Now, what I want to do is this. I can hit second mode real quick. Now I want to go back and explain something because this is the fundamentals. Celsius is an input, right? So this 10 is an input. It's an X value, right? And then this Fahrenheit is an output. Okay. So algebraically, this is what they're doing. I'm going to show you algebraically. They're saying, okay, F equals 9/5 times 10 plus 32. And so you could do that. So that's going to give you 50, right? Okay.
Yes.
Now, so you can chug and plug it. That's fine. But you need to put the investment in right now while it's linear equation, because when we get into logs and we get exponentials, when we get quadratics and logistic functions, those algebraic techniques of all the properties and everything, you're not going to remember. And I'm not going to go over them because I'm going to be solving them by the calculator. Because all they're going to give you after they give you an equation is either an input and ask for the output, or they're going to give you an output and ask for the input, right? So really this one is 2 equals 9/5 C plus 32, right? And I mean, we could subtract 32 here, and we get 30 equals 9/5 C, right? And then we go multiply both sides by 5/9. So that's going to give you 16.67 equals C, right? So that's how you would normally do it in an algebra class, or if you've done it by hand. I'm going to show you how to do this on the calculator, and know that if you typed it in correctly, boom, you got it done. Okay. So, all right. Second window gets me to my table, and this asks on this independent is the X value. And what it's set up, I can either have it on auto or ask. If I have it on auto, then it's just going to generate me a t-table. And it's going to start at -4 and it'll step it by 1. My X's are changed by 1. Now I can change that to make it change by a 10th if I want to. But we're customary X changes by 1. Or I can put it on ask, and when I hit ask, when I go second graph, which says table up in blue, let me hit delete right there. Now I can put in 10 and hit enter, and it tells me that it's 50, right? At this point, I like to ask because maybe it's some decimal. Maybe it's like 12.8. You don't want to have to adjust your steps on your tables to accommodate that. It's easier just to be able to ask and just put in an X value, right? So that's how you would do that. I mean, I could pick anything. I could pick, that's 10. I could pick 15, boom. 90, boom, right? Anything that I pick, it's going to, once I hit enter, it will evaluate it because my equation is in Y1, right? So that's how you get the input, the A, right? So now let me show you how to define the B part, and that's at 2. So I'm going to go Y equals, and what I'm going to do, if you remember anything as far as linear equations, when you have Y equal to a number, you have a horizontal line, okay? So what you have to understand is when you are given an output and you're asked to find an input, then what you're really doing, if you had the graph in front of you, you'd want to draw a horizontal line at that particular output and give me all the X's that correspond to where it touches the graph, right? That's really what you're doing. Well, we don't have that luxury. They just gave us an equation and said, hey, here's an output, find the input. We don't want to do, you know, like I said, it's easier to do it on linear equations, okay? But we don't want to do this when we get into all the more complex functions like exponential logs and all that. We want to be able to let the calculator do it for us. So when I put the in 2 and Y2, it's going to draw a horizontal line. Now, let me show you what's going to happen. I'm just going to hit graph. I don't have a clue where it is or what my window limits are or anything like that. My first thing I'm going to do to get my calculator graphing set up correctly to even give me an idea of a starting point is I'll go zoom 6. And what zoom 6 is, guys, it sets the x-axis and the y-axis to a -10 to a +10. Okay. Now, you note that the blue, well, I said the blue, it should be the red. The red is showing up, but the blue's not, right? So the red, there's 2. If I'll hit this, if I'll hit zoom 0, what it's going to do is it will keep my x's from -10 to +10 right here. And it'll adjust my y values, the viewing on my y's, to accommodate all outputs for x's from -10 to 10. And if you can see over here on the far left, down at the bottom, we see a red line, right? But we also see the blue line, and we know that it's crossing somewhere below -10, right? So here's what I'm about to do. I'm going to hit my window, and I'm going to say, for grins and giggles, -50. Well, if I can type that in correct, I will. 50, right? I'm not going to change my X max. I really don't care about changing my scale right now at this point. I'm just going to move my left window limit out. I'm going to hit graph. And then I'm going to hit zoom 0. Now, what that did is that's from -50 to +10, right? And it's showing me all my outputs, which is a blue line. I want to know where they intersect, right? So anytime you have to do any kind of calculations on a graph, then you're going to hit second trace, not the trace button, because you need precise, not a roundabout. You're going to hit second trace and go down to number 5. And it's as simple as this. Enter, enter, enter. Okay, and you can see that it's negative 16.67, which is what we calculated, right? Didn't we calculate negative 16.67? No. You know why? Because your professor left off this. Negative 30, which would have gave you that, because 2 minus 32 is negative 30. Didn't make you catch that. Okay, so that's there. So there, even in the haste of working the problem, by hand gave me an error, but if I look on the calculator, look what it gave me. It gave me the correct answer. So you're less likely to make a mistake, okay? I highly, highly, highly recommend you learning how to use your 83 and 84 calculator. If you don't have one, beg, borrow, don't steal, okay? But if you put it out there on any kind of social media, if you don't have one, and ask, that you've got friends that are nerds, and if you don't have any friends that are nerds, you need to find some, okay? And get a calculator from them. So there. Kenny, did that help you?
Yes, sir.
Okay. For the rest of y'all, and there's still a good bit of y'all on here, I really need for you to learn how to do that on a calculator, okay? Trust me, time well spent now is going to be paying off dividends later. All right, so that was problem 11 and 1.5. Which other ones do y'all have?
Problem 15 and 1.5.
Oh, okay. All right, who's this? Who am I talking to?
Wendy.
Oh, okay.
It's Wendy.
Okay. Hey, Wendy. All right. Oh, yeah. Kennedy, TI Inspire. That's the one above the 84, right? You're good. You're solid. Now, I can't, it should be the same keystrokes, but did you say 15?
I did.
Okay, sorry.
You did one like it on the video, but the slope's different on the one on here, and I've tried everything I could.
Okay. Well, we're going to look at it and make that get a little bit bigger, and then I'm going to take a picture of it, and then I'll blow it up even more. Okay. Okay, let's see what we got over here. I don't want that. Shoot. I want this. All right. Okay, so when you're looking at these, the graphs, when you click on them, they'll get a little bit bigger. I will tell you a trick on that. See this little button right over here? I'm using Chrome, so I can hit my zoom, right? I can increase my zoom, and when I hit that, and then increase my zoom too, and so it will really make it big. So that's a hint. All right, so they want slope, right? So let's kind of look at it. I know it crosses here, right? So there's a good point. That's 0, 0, right? Now all we got to do is find another crossing, and it's crossing there, right? So let's see. How far is it going up? Well, that goes by thirds, right? Doesn't that go by thirds? So if that's 1 and there's 3 sections, so that's what? 0.33, right? Y'all agree with that, Wendy? And then my change in
I do. On mine, I got the answer to B as 0, and it was correct, but I couldn't get the answer to the other ones.
Okay. Well, since the rest of the answers are probably based off this, I want to go ahead and finish this. So I've got change in y over change in x, which is 0.33 over 1, which is just what? 33 or a third, right? And slope a third. So let's go back. The y-intercept would be 0. Do you see why the y-intercept would be 0 right there? It crosses the x-axis at 0, so the b is 0. So if I were to write this, it'd be 0.33 x, right? I could do plus 0, but really, if I add 0 to it, I'm really not changing the equation itself, right? So let's look and see what else. Okay, use your estimates from to write an equation. Okay, man. Okay, yeah. There you go. 1/3, 1/3, right? What slope did you? Wendy? What got you on that writing the equation?
The only thing that I actually got on there correct was B equals 0. That was it.
Okay, so you know how to find the slope, right?
Yes.
Okay, I could have, if I wanted to, I could have made another point, right? I could have said, okay, that's 1, 0.33, right? And then I've got 2 points I can find slope. I can put it in traditional y2 minus y1, right? Over x2 minus x1. Or I can just look and see how much is it really changing, which is really what this is doing, right? There's changing. Man, okay. This is really change in y over change in x anyway, right? So once you find slope, that's A, right? B on this right here, part B is the y-intercept, which is B, which for this particular problem is 0, and we don't put it there. You know, it's left off from the equation if it is 0. And then it says, okay, you found slope, you found y-intercept, now write me the equation, which would just be y equals mx for this one. Okay. So did you have problems with the slope to begin with, or because you said you got the y-intercept good? So was it the slope that got you?
It was. I just could not figure that one out. I was trying to figure out. I was thinking that the points had to cross somewhere close to the middle, and I couldn't figure out where it was crossed.
No, they got to cross at a perfect grid. See this right here is a perfect grid mark. That's not. This one is. No, yep, no, right? So, and then
I misread the question because I was thinking that it had to cross, like the red line had to cross the either the y or the x-intercept somewhere, and that's where I was missing.
Oh yeah, no, It didn't have to cross that. It will cross. I will tell you this. It will cross the y-intercept, right? Or the y-axis, I should say. It'll cross the y-axis. It has to, unless it's a vertical line, right? That's about the only one that would give you a scenario that probably 99.9% of the time wouldn't cross the y-axis, right? But everything else should. So, you know, I typically find the point on the y-axis and then start moving right up the line or down the line to find me another grid point where it crossed perfectly out of grid, and then just calculate slope from there. Yeah, most people, just depends on how long it's been since you've done slope. Some, because of the problems leading up to this, where they did the y-intercept and x-intercept, so it kind of give you that looking for a point on the x-axis, right? Which is kind of misleading. Okay, so that's probably what got you a little bit.
Yeah, it is. Thank you.
Yeah, no problem. Trust me. Every problem that y'all are doing in homework, I'm doing as well. There's just some of these I'm putting on the videos are ones that I feel based off teaching. Gosh, I've been out there 10 years. That I know my students probably would have a question. So, all right. Okay, guys. Anything else? I know it's getting late, and I do apologize. me do this real quick. Yeah, I got that. Let me do this.